So in this video, we are going to look at how to calculate half-life. How do we calculate half-life if you are given the initial amount of the sample and of course the amount of the sample that remains after a time has elapsed? Okay, so that is what we are going to look at mainly. So we have there's a question here that we are going to use, and the question reads: in an experiment to determine the half-life of a radioactive isotope, it was found that the activity of the source dropped from 2000 count per minute to 250 count per minute in 30 minutes. The question is, calculate the half-life of the radioactive isotope. Calculate the half-life of the radioactive isotope. How do we calculate the half-life? So now, in calculating the half-life, the first thing you need to know this formula. So what should come to your mind is this formula. So what is the formula? N divide N naught is equals to half raised to the power N, where N is a sample or the amount of sample that remains after a specified period of time or after a period of time. And we have N naught, which is the initial amount of the sample or activity. And we have small n, that is the number of half-lives. So now, in order for us to calculate half-life, the formula that connects half-life is this one. So half-life, that is T. So for T, half, this is the half-life. Okay, half-life. So half-life, in calculating half-life, we use this formula. Okay, we use this formula. Now, for us to apply this formula, we need N and of course T. This big T is the time that elapsed. Okay, so T is total time elapsed. That is T. Okay, so when we have the total time that elapsed, and of course we have N, we can now calculate the half-life. But we can only find N using this formula. So this formula is the one that we use first to calculate N. Then we can come now to apply this one to find the half-life. So let us start solving. So we are going to start by finding N, and therefore let us have the information that we need. So if we are to collect the information from the question, if you look at this part, the activity of the source dropped from 2000 count per minute to 250 count per minute. So which means the initial, which is N naught, was 2000 count per minute. And of course, after a period of time, it dropped to 250. So which means the sample that remains for activity was 250. So our N is 250 count per minute. And what else do we have? 250 count per minute in 30 minutes. So the time that passed for the sample to reduce to 250 from 2000 was 30. And that is the time or total time elapsed. So 30 minutes. So this is the information that we have. Now we want to start by calculating N. Okay, so in calculating N, we are going to apply this formula. N naught is equals to the power N. What is our N? The sample that remained to activity was 250 divide 2000, which is the initial, is equals to, this half in decimal is 0.5 raised to the power N. So if you divide 250 divide 2000, you are going to have 0.125, 0.125, which is equals to 0.5 raised to the power N. at this point, you introduce the log to base 10. So log to base 10, you introduce log base 10 to all sides of the equation. So you're going to say log 0.125, also the other side, log 0.5 raised to the power n. So now after introducing a log, you know that you want to find, remember your target is to find n. So this expression can be written as log 0.125 is equals to, so this one, the n would drop this side. So we are going to have n log 0.5. Okay. Now we want to find n, so which means we divide both sides by log 0.5. Also this side log 0.5. Log 0.5 and log 0.5 goes. So n is equals to log 0.125 divide log 0.5. And the answer that you find is 3. So our n is 3 in this case. So that is how we find n. Okay? So now, there's another way, of which the easy way to find n, if you are given the initial amount of the sample and of course the sample that remains. So what is the easy way? So this one works normally when you are given the sample that, the initial sample or activity, and also the one that remains. So this one, this is how it works. So you have the initial, which is 2000, and you have the one that remains 250. Okay. Now half-life is the time taken for half of the unstable nuclei to decay, or it can also be defined as the time taken for the activity of the radioactive sample to fall to its half original value. So the keyword here, when it falls to its original value. So from 2000 up to 250, there are a number of half-lives here. Now how do we find them? Since we are saying when it falls, the original sample, when it falls to half its original. So we are going to divide this one by 2. And what are we going to find? We are going to find 1000. So this is the one half-life. Then we divide this one by 2. We are going to have 500. And this is the another half-life. When we divide this one by 2, we are going to have finally 250. So when you divide the original, the first one, by 2, half-life of it, okay, it goes to, half of this, it goes to 1000. So we have one half-life here because it has the amount of the sample has gone to half of its original. Then now, this one becomes the initial, and of course you divide by 2 to find the half-life. So it falls to 500. That is another half-life. Then if you divide this one as the original, it goes to 250 finally, which was given. So from here up to there, if you are to count number of half-lives, you are going to find that 1, 2, 3. So that is the number of half-lives that the sample, those are the number of half-lives, okay, for the sample to reach 250 count per minute. So number of half-lives still remains 3. So that is the easy one that you can use also to find number of half-lives. Remember, this one you only apply it when you have the initial and of course the last one, which is the sample that remains. All right. Have we calculated the question? So we've not answered the question yet. After finding n, what are we going to do? Do we have t? Because we need to apply this formula for us to find the half-life. But we have t. So t is the time that elapsed. If you look at this question, the source dropped from 2000 count per minute to 250 count per minute in 30 minutes, which means the time elapsed was 30 minutes. So our capital letter T, the time elapsed was 30 minutes. and therefore applying in the formula, we are going to have half-life is equals to, if we are to make half-life the subject of formula, these will just exchange the position, and we are going to have period that elapsed or time elapsed divide number of half-lives. Therefore, finding half-life, we are going to find what was the period or time elapsed, 30 minutes. 30 minutes divide the number of half-lives, which is 3. So therefore, the half-life, if you divide 30 minutes divide 3, you are going to find that is 10 minutes. So the half-life here was 10 minutes. So take note, the units of half-life are the units of time, because just time taken, okay, for half of the original amount of the sample activity to decay. So it's measured in whichever units of time is given. That is the one that you use. Okay, so that is it about finding the half-life.